Kia ora and g'day everyone. Great to have you with us today. We've gathered a fresh panel from the experts at Markham, and we're keen to get into the science and practical challenges of concrete curing for today and tomorrow. We'll quickly introduce ourselves before we dive in. I'm Brendan Stead, Marketing Coordinator based in Bundaberg, Australia. I'll be chairing the discussion, including passing on your questions. On our panel today, we've got Hayden Prestige, who's beaming in out of Auckland, Markco and Brendan from our Napier office, and Will Pepping, who's in Sydney. Hayden, can you tell us a little bit about yourself and the others can follow on?
Cheers, Brendo. Yeah, it's good to be on today. I, as Brendan said, work across New Zealand and Australia projects and the sales and marketing side, but yeah, very, very keen to be part of this one. It's a good topic, concrete curing and why it's so critical for long-term durability, really. So that's good. Been with Markham for just over 6 years and came out of the construction industry. So that's a little bit about me. Mark, all yours.
Yeah, g'day everyone. My name's Mark Coburn. I've been with Markham for just over 12 months now. I came on board last March as the operations manager for Australia and New Zealand. So predominantly just looking after the application side of the work we do, which have things like concrete curing have a direct impact on that. So yeah, really looking forward to today's little webinar and just nutting a few things out with everyone. Over to you, Will.
Cool, thanks Mark. My name's Will Pepping. I'm based in Sydney, Australia. Work predominantly in architectural design and delivery of projects in the construction space. So working alongside the Hayden in the earlier phase and assist Mark in the operation phase as well. As Mark said, really cool topic today. And definitely in Australia, we find curing's very important just based on the heat and the temperatures over here. So look forward to answering any questions. Don't be shy. If I can't answer them, I'm sure Hayden and Mark will be able to help you guys out. So fire them across.
Very good. Thank you so much, everybody. So the presentation will be about 20 minutes, and as Will mentioned, it'll be followed by live Q&A. You'll find a Q&A button in the bottom toolbar, and we'll be happy to look at those at the end of the presentation. So without further ado, we'll kick this off. Hayden, can you tell us a bit about the basic science of concrete curing?
Yeah, absolutely. So a lot of people, I guess, think of concrete curing as concrete drying out. You know, you pour your slab, you leave it and it dries out and it cures and goes hard. That's actually the absolute opposite of that. Concrete cures by retaining its moisture. And so we all know concrete's made up of, you know, standard concrete. You got cement, you got your aggregates, your stones, your sand and water. And these components, there's a chemical reaction going on with the cement and the water, and that's what's needed. So that moisture is really needed for curing. And so I guess a lot of people talk about air curing and things and just leaving my concrete, but you're really not giving concrete its best from day one. Curing is all about moisture retention, being able to feed that cement and to grow that, what we call calcium silicate hydrate, grow those molecules inside the concrete and really bind the concrete together and create its strength. Does that make sense?
Yeah, it's good. So the strength of the concrete is tied up in the curing process. Is that right?
Yeah, very much so. I mean, strength of concrete comes from various parts, you know, your cement contents and what your mix design is and things, but a big portion of it is absolutely that. Yeah, it's in the curing, and that gets overlooked by a lot, really. You know, you design your mix right, you bring it to site right, it's mixed right, but then it's poured and placed well, but then it may be left and not cured, and that's really providing some areas where it's susceptible for premature deterioration, really. So yeah, that's a good point.
Fair enough. So I guess we should be talking about the flip side of that. No doubt everyone's being very careful to follow best practices on site. Mark, you see a few things as part of your project management. What actually goes wrong?
Yeah, absolutely. One of the big factors we encounter, obviously, is the environmental impacts. Being across New Zealand and Australia, we face very extreme sides of the element, those elements. Obviously, we get the very hot as well as the very cold. And these do have the direct impact on the curing of the concrete, which in turn relates to the overall performance and durability of that concrete. Hot conditions for us, hot, humid, windy conditions will essentially make your concrete set faster, which may seem like a good thing at the time. You will get high early strengths in your concrete, but overall you will get a reduced durability. As you've got such a fast, high early strength, it will actually slow the overall strengthening process of the concrete as it ages, which can directly impact the durability and the life of that concrete. Plastic shrinkage cracks are another issue that we come across in the heat conditions, and that's just the water evaporating too quickly out of the concrete, and it just starts to form those cracks across the top, which no one really wants, especially if you're going for an exposed slab look. Probably more so here in New Zealand, the cold conditions down the deep south, that has a different impact, obviously, on the concrete. It actually slows your hydration process, and in those extreme cases, the below freezing cases, it can actually stop it completely. And this can really impact the overall strength of your concrete, not only at the beginning, but long term, but especially at the beginning, because it's such a slow process. The concrete's more susceptible to cracking because it doesn't have the strength to resist any expansion or movement in those earlier days with the concrete. So that's some of the issues we come across. Another thing is bleed water. Bleed water in the concrete is a good thing. Essentially, it's just free water that hasn't reacted with the other products in there. So it's just sitting there free, and as the heavier aggregates settle, it pushes the free water up, and that starts to come out through the surface. Now, normal bleed water, you'll see a nice uniform across the surface. It'll be just nice and natural. When it becomes trapped and you start to form channels, that can cause some bigger problems, like weakening the bond between the paste and your aggregates, as well as the actual paste and aggregate, and reinforcing. So I think Will's going to talk a little bit about porosities in concrete and how it has an overall impact in the life cycle of the concrete.
Yeah, cool. Thanks, Mark. One little point I'd like to probably reinforce a little bit is there is actually a big misconception about not needing to cure in cold temperatures. Do you find that in New Zealand? Some parts of Australia obviously do get pretty cold, and I have come across several people in the industry who have that conception that that you don't need to cure in the winter months because of the temperature. It's just a bit of a reverse.
Yeah, we do see that a bit, and the reality is you still need that moisture in the concrete, but again, you don't want it to freeze, so that can cause you really big issues. It's a different sort of curing in the winter. Obviously, we use our Akron products that go in and they cure internally, but externally, it's also about keeping the surface at a good constant temperature, using things like you can use heated formwork, thermal blankets are another good one. It's just maintaining that constant pressure, constant temperature for about three to 7 days, I suppose, on that concrete to ensure that you're still getting your strength gains overall.
Thanks for that. I'll just quickly talk about cracking in concrete. So thanks, Marco. Just in regards to cracking and the porosity in concrete, by not curing your concrete properly can lead to cracking, which simply opens up your concrete to allow potential contaminants into your concrete slab that speeds up that or accelerates that deterioration process. So you've got contaminants such as carbonation, chloride attacks, another one, and general acid attacks. So by curing your concrete to standard or exceeding the standard, you're minimising that risk of potential shrinkage cracking or just general cracking, therefore giving your concrete structure a longer life and making it more durable for the lifespan of that asset. Therefore, you're looking at minimising potential ongoing maintenance costs, repair costs, and contributing to a better carbon footprint as well, which is pretty important in today's world.
That's quite a collection of challenges, Will. Could we have a bit of a dig in on the science of that cycle of deterioration you're talking about? Hayden, is that something you can give us some of the detail around?
Yeah, I guess it's interesting. Concrete. A lot of people think of concrete as as your most hardy material out there. I'll build, even if I up my MPA, I'll take it up to 60 MPA concrete or whatever, and it'll give me the strength needed for durability. But really, regardless, concrete is absorbent. It will take on water, and it needs protection. And so if you get some micro cracking or shrinkage, drying shrinkage cracking, plastic cracking in that curing phase, really you're just accelerating that process of letting moisture into the concrete. And with it, water basically carries in these contaminants that Will was speaking about. Like there might be acid, there might be some carbonation. Chloride is a big one in like marine structures, or even wind-blown chlorides. Like most of New Zealand and Australia is within, it's pretty close to the coast, most of it. And these sort of things, these sort of things play on concrete long term. So that's what needs protecting against. And to do it right from the start is get that curing process right, because that means you're giving the ultimate protection to your concrete from day one. Water curing, I guess, is you're really a benchmark if you can do it properly. And there's a big if there now, because the practicality of doing it on sites is to actually flood your slab consistently for 7 or 15 days consistent it's just not practical, from program point of view of one, high rise, you've got runoff, etc. And then a lot of car park structures, etc., they've all got falls on them, so you can't flood the slab. So there's these sort of things, but so you need a system that is equal to that water retention of a flooded slab. So does that make sense, Brenda?
Yeah, that's good. That's good. So the deterioration challenges are something we're seeing frequently, aren't they? What answers do we have to offer? Marco, can you help us on that? Have you got a case study or something we can talk about?
Yeah, I think we've got a couple of case studies. Do you want to share them on your screen, Brenda? I think the first one we were going to talk about is Lenli building in New Plymouth. That was a hydrogel admixture was used in that concrete mix. So effectively, we were putting our product in at the start, which means it's fully encapsulated right through that concrete. It provides enhancement in the curing and permanent waterproofing benefits. Another thing about our admixtures is they actually support the workability. So it makes the concrete more workable and reduces the risk of people adding extra water to it in order to achieve a more flowable mix. So it works in maintaining your water cement ratio, as well as waterproofing that concrete. So it's very good, and for us to get it in there up front makes it a lot easier, and then we can come and support that curing with a bit of A2000, Akron 2000 over the top, which just gives you that double reassurance, really.
That's excellent. I wonder if you could tell us a bit more, Hayden, about the actual science of what Mark was just describing, the Akron treatments.
Yeah, so Markham has utilised it's a colloidal silica-based hydrogel treatment, and we've utilised this technology for over 26 years now in Australia and New Zealand. It's a technology out of the United States, but if we can just jump into this image here and have a bit of a look, we'll try and explain what's happening inside here. So you can see that look at the far right where you can see those red capillaries. We'll just look at that section for now. So that's like looking inside your concrete matrix. You've got the big grey stones or your aggregates. You've got your grey cement paste, that's your calcium silicate hydrate. And then you've got all these red lines and your water molecules. So like Mark was talking about earlier, only a portion of the water that's added into the concrete at the mix is actually utilised in the mix, and that finds its way back out, either up through the surface through bleed water, or it drains out through the bottom and things like that if it's not protected. And it leaves these capillaries, it leaves these roads that really become a transport system for free moisture to get back into the concrete. And with it, it carries these contaminants and things, and it gets right in to your depth of steel, which is your problem. That's where you start that corrosion cycle, because you're allowing moisture and oxygen into your concrete. So what we're doing, I guess, with the Akron hydrogel treatments is coming on as a cure, spray apply at the surface. We get a really deep penetration, 150 mils into the concrete, and we're coming down these capillaries and we're transforming the moisture in the concrete to a hydrogel state. So it holds and retains that moisture. So its ability to keep feeding the cement, the ability to keep growing those molecules and making those bonds really tight between the aggregates and the reinforcing and all the cement bonds really tight. So it's, and as far as moisture retention goes, in that state of a hydrogel, it holds it equal to a 14-day water cure. So, that's the effect we can get. So I don't know if that covers what you're thinking, Brendan.
Yeah, that's excellent, Hayden. I love the immobilising the moisture and arresting the deterioration by immobilising the moisture.
Yeah, not only curing, but because we're filling up those capillaries, because we're blocking those pores, it's protecting your structure, for long term. It's not allowing moisture to get back in. It's not allowing chloride. It's not allowing acids to get back into the concrete. So
Fair enough.
If you stop moisture migrating through your concrete, you stop that whole deterioration process, don't you?
Yeah, I mean, probably 99% of concrete's issues are from moisture getting into the concrete. So yeah.
That's excellent. Will, one for you. We've got a case study on this side of the ditch.
Yeah.
Walk us through what we did here.
Yeah, great. So this is a project in Newcastle, a couple of hours north here of Sydney, where we have.
Sorry to interrupt. I just noticed on LinkedIn today the builder was celebrating popping out, so it was great.
Yeah, this is a case study on a project up in Newcastle, as I said, few hours north of Sydney, where we've got a below grade basement that we waterproofed without a membrane. Now this specific project was a few meters below the water table, so it had a head of pressure coming up through that floor, through that basement slab. So we utilised the Akron 300 admixture, as Markco had just previously discussed. We utilised that product for shrinkage control. It also has a crack healing ability of 0.5 of a mil, so controlling those cracks. As I mentioned before, if we can control those cracks, we're stopping any type of form of moisture coming up through or coming into your concrete, therefore protecting that reinforcement steel for the life of the structure. And then also, as Marco also mentioned, we gave the concrete a really nice workable, flowable mix, which we had great feedback on from the concreters, which was also great. The second part of this process, we cured it utilising the Akron 2000 product that has that penetration depth of 150 mil, equal to a water cure of 14 days water ponding. The beauty of this product also for a construction timeline, benefit is that concrete is now really durable on the surface. It's been cured really well, and we've improved the abrasion resistance significantly, therefore meaning the builder doesn't need to go and put a topical sealer on top of the concrete to seal off the concrete. And also compatible with all line marking paints. Lastly, it doesn't also contribute to tire squeal, which is quite a big benefit in these apartment buildings that are in built-up residential areas. Anything I've missed, Brendan?
That's excellent. Well, the benefits must represent real value to the asset owners as well as the benefits of construction stage.
Yeah.
Now, I see there's some audience questions coming in, which is brilliant, absolutely brilliant. Don't forget that Q&A button down the bottom, people. I just wanted to ask Marco, one of the questions which almost always comes up, so we might as well meet it head on. What is the warranty that Markham offers on these systems?
Yeah, so a standard Markham warranty on our moisture control waterproofing systems is a 15-year warranty. We give that out regardless of anything else, that if we have applied the product to our standard, hence why we have an operations team that go out and do it. We manage the application of it. We know it's been applied right. Therefore, we have the confidence as a business to back it up with a 15-year warranty, which is particularly helpful if you're putting floor coverings down. We come in, we treat your concrete. You have confidence that you can lay your floor coverings, provided all our standards have been met, and knowing you've got absolute assurance for 15 years. If there were to be a problem due to moisture, then Markham would step up and take care of that. That's how much faith I guess we have in our product. We know it works. It's been in play for 26 years now across 2 countries, plus however long it's been in the US. So I think, yeah, it's pretty reassuring to know that you've got a 15-year warranty behind you when you are doing projects like that. Absolutely excellent.
Right, we're just going to move to the audience questions here. They're coming in thick and fast. This is great. Perhaps Hayden, if you want to take this first one, does the hydrogel treatment affect the bond of applied concrete protective and decorative coatings?
Good question. Sorry, probably didn't cover it fully earlier. A short answer, no, which is really good. So the colloidal silica hydrogel, we're not actually adding anything that's foreign to concrete, because we're creating more of that calcium silica hydrate. That's all that the reaction is doing in there. That means anything that's formulated for the use of concrete, like adhesives or membranes, or any topical applied coatings, those sort of things. Something Will mentioned about line marking and things in the cover. That means anything that's formulated on the use for the use on standard concrete is compatible with Akron treated concrete or our hydrogel. Hopefully that answers that one.
Very good. We've got a question. How does the Akron treatment also stop corrosion of the concrete and reinforcing? The one for you, Will.
Yeah, great. Thanks, Brendan. Just throughout our brief presentation, we touched on the fact that our Akron hydrogel technology immobilizes moisture and it's coming inside your concrete. Simply how that works is by mobilizing moisture, we're not allowing moisture to bring any contaminants into the concrete, therefore corrode that reinforcing steel. Anything else to add on that one?
It's just locking up that moisture so it doesn't have the opportunity to react around your steel and form rust and corrosion and things like that.
That's good.
Just to touch on that a little bit further, even though a corrosion may have started in a structure, we've worked a lot into like marine sectors and things like that, like wharves. We've been able to hold that cycle and really extend the service life from that point. So by what, like Will and Mike was saying, by mobilising that moisture, you're taking that out of the equation and you can just hold that state. So you can get a lot more. Oops, my screen's gone very dark.
I'm jumping a little bit out of order here, but there's a very similar or very closely correlated question here. Why does moisture getting into the concrete matter when the concrete has internal moisture? So I'm thinking that might relate to what you were just discussing.
Yeah, the mustn't have paid our power bill in this little cubicle here, so it's gone nice and dark on me. But yeah, absolutely, it's about the free moisture getting into and what the moisture carries with it. So yeah, that should be more than that. But moisture in concrete is not going to kill it. It's what it brings in with it really, and that can start the corrosion cycle.
Yep, that's good. Good practical question here. Might be your department, Marco. Can we use the waterproofing admixture for shotcrete for basement design? AHD 1.5 meters.
Yeah, absolutely. I can see why not. I believe we've done some shotcrete projects already, Hayden, probably, and more that's becoming more and more common. Also, another aspect would be your self-compacting concretes as well. But yeah, definitely can be used in those.
Just to touch on that one, we're actually we've got a few shotcreters over the side of the ditch that are using the Akron admixture and all of their shotcrete. One of it's obviously for its waterproofing properties, but secondly, we're finding the workability or the contribution to workability that the Akron gives is a massive benefit. I had a stat not long ago from a shotcreter that said he managed to drop his PSI from his gun from about 3,500 down to 1,900 PSI. So he said that alone saving him a heck of a lot of money and downtime. So yeah, definitely you can use admixture for shotcrete.
Yeah, that's good. And just to touch on that a little bit further, so part of what Markham does, one of its offerings is a full design solution to basement waterproofing. We do a lot with that now. So by incorporating the admixture, a spray applied cure, and a joint gasket system, as we can give you a full warranty waterproofing system in lieu of what could have been traditionally tanking. So yeah, it's a strong point. It's good.
Very good. Good question here. Does Akron do away with the need for plastic under the concrete?
No.
Or whether the question is around waterproofing membrane or the plastic that's used to cover the underlying substrate for the formwork type. So, you want to touch on that one, Will?
Yeah, no, plastic is still required. It is industry best practice to use the plastic film under your concrete because it does cure that bottom side of the slab, and it gives the concrete more ability to hold that moisture internally inside your concrete, so it's not escaping out, therefore giving you better structural curing.
There you go. I'm learning something every day.
There you go. I think that's right. Is that right, Hayden?
No, absolutely, yeah, it's absolutely right, because basically if you didn't have it, the ground would just pull the moisture out of the concrete, and so it would, like Marco was talking about earlier, is you get that, or you're losing your moisture, you're losing your curing, and and yeah, you'll end up with bad quality concrete.
Fair enough. Tandy asks, do I need to use some of your Akron treatments on my residential slabs?
Well, that depends on what you're trying to achieve. You're trying to achieve structural waterproofing in a basement situation, yes. Then you've also got the Akron spray applied products that are massively beneficial for polished or honed concrete, for example, because the concrete becomes really, really hard, which gives you a better finish. Then also if you've got carpets and vinyls, for example, the Akron 2000 gives a moisture-proof slab, which allows you to put your vinyls straight over the top of. I might have missed a couple of points there, but in general, yes, you can use the Akron treatments on your residential slabs.
Yeah, that's good. It touches on the point of what the particular need is project by project too. Do these treatments benefit a structure to be more resilient to seismic activity? It's definitely one for the New Zealanders.
You saying we have more earthquakes over here? It's a constant earthquake, I think. Yeah, well, I mean, it doesn't stop your concrete from shaking, put it that way, but it's not really going to provide any more strength against it. What it will do is, say if cracks appear in a basement scenario or even in a precast structure or something like that, the self-healing ability will start to activate, and it will take on free moisture that maybe run off or something and heal that crack to stop ingress of moisture, things like that. It's not as though it's going to protect your building from an earthquake. Don't think we could quite claim that in our warranties, but it'll just give you the extra protection of on that remedial side.
That's helpful.
Fact it does help with the self-healing and speeds up that process, which concrete does have naturally. I think that's probably the biggest benefit in that seismic sort of activity area, definitely.
Yep, that's very good. Does the concrete additive prevent plastic shrinkage when placing concrete in hot, dry, windy conditions? Or does it just provide 14 days curing?
This be one for you, Markco. You covered this off.
Yeah, no, it definitely does. So it's equivalent. We say it's equivalent to the water curing aspect. The positives are is you don't have to have your taps running for 7 days with continuous water. So yeah, it does work. I mean, some good examples are our team over in Western Australia. They work in some pretty extreme heat conditions, sort of 40 degree ambient temperature. So you can imagine the actual temperature of that concrete. And they are proving that it's very successful. A1000 as a curing product, and it does preventing shrinkage cracking in those particular slabs. So yeah, definitely.
I think with that, Nigel, is the additive, but to reduce those that curing in in hot and windy conditions, it would be the spray applied products that Markco was talking about. Not so much the additive. The additive, you're looking at a shrinkage reduction. I think it's about 30%. Is that right, Brendan? Something like that.
Yeah, it's difficult to quantify without. Yeah, it varies by mix, unfortunately. So it's not something to put an exact figure on.
Because you're dealing with wind, you obviously want to protect that surface, so that's why you'd need the spray applied Akron 2000. We've done projects in Darwin, which, as Markco said, we actually utilised the Akron 300 and also the 2000 as a 2-in-1 system, and they were pouring large 1,000 square metre slabs throughout their hot months, and this project, we've given I think it was a 15 or 20 year waterproofing warranty, and there's not one shrinkage crack on those slabs. So the proof is in the pudding.
Very good. Very good question here. As a consulting engineer, how do we go about specifying into our design, or is the hydrogel typically requested by contractors to expedite the program? Tell us about that, Hayden.
Yeah, great question. It's yeah, absolutely. We do a lot in the specification and design phase. We'll work with you as a consultant to fully understand what your project needs, what your requirements are, and then we work with like NetSpec and MasterSpec in New Zealand. So in these type of arrangements where we have specification that you can include on your project, written onto your plans, written into your documentation. And then the second part of that question, you know, can contractors just take it on further down the track? We work in that phase as well, but it's best overall is to get in early, design it right, and get it right from the start, and then it's written into your plans, your program. Everyone knows what is needed, and yeah. So it's we do a lot in that design phase, and that's Will's job, and we've got dedicated team members to help out with that.
Yeah, there are a couple of obviously technical points you need to cover off. One being crack tolerance as a consulting engineer. So that's what we discussed with you, and we do find, I'm not sure what it's like in New Zealand, but over here in Oz, we find there's a lot of design and construct projects that we also get involved with civil contractors, etc. But preferably at the front end of the project is definitely our preferred way of doing things.
Very good. One last one, which I think I'll direct to Markco. Can concrete freeze in low temperatures during curing?
I guess, yeah. The concrete itself won't freeze, but it's the moisture inside. So below temperatures of 0, you can obviously, it can halt the hydration process completely, which means you will have no strength gains in your concrete. Some of the common things that can happen is there is physical damage to the surface of the concrete. It will scale, it will burst, and delaminate it and just crack and basically turn into a mess. But on the flip side of that, there is ways around managing that, i.e. choosing when you place your concrete, heating your aggregates, using thermal blankets. There is loads and loads of options, but yes, to answer the question, the moisture in the concrete can freeze. Yeah,
someone once explained to me, I thought it was a good analogy for my little mind. If you put an ice cream container of water in the freezer and then pull out, it comes out at a different size. It expands and goes like that. So it's and that's what your concrete will do with it. And when it expands and contracts, that's when you get that cracking, and that's your problems, isn't it?
Yeah, absolutely. And because your hydration has been halted, especially in those first 7 to 14 days, even up to 28 days, there's no strength there to resist that expansion. So yeah, hence the cracking and things like that that's going to occur.
That's fair enough. Well, thank you all very much for your time on board today, and thank you for all of those who came along and joined us. We really appreciate it. It's been absolutely brilliant questions, and recording will be available. We'll send out a follow-up email with contact details and an offer of the recording, and we'd like your feedback. Thank you all and have a great day.
Thanks.
Thank you.